Yeah. So, hello everyone. My name is Sergey Gribnyak, and here our colleagues and myself, we are starting the second AMA session. Last time we already introduced ourselves, so if you need to know who we are, you can go to the you can find the recording of the previous AMA session where we were doing the introductions for each of us. And now we will go straight to the point, addressing the questions you were asking us prior to this event. So I am passing the word to Alexander, and he will start today.
Hi, I'm Alexander. I am team lead in Waterfall. So a lot of people asking us about Faucet, where he can get test water. Maybe I will share the screen and show to us where you can get test water. When you go to Waterfall Network main site, you can go to documentation, and in get starting menu, you can go to Faucet get water and have a lot of different links to our testnet. For example, we have a link to testnet 7, and you can paste your address. For example, I don't know what is it, and send me, and this address will get 4,000 water. Also, a lot of people ask us about Bridge, how he can transfer any token from different blockchain network to us. We have Bridge. Bridge works on testnet 2, so it's testnet 2 is deprecated, and we will launch testnet 8 soon. So, and the new bridge will work on testnet 8. So you can read technical information about our bridge on our documentation site. Also we have some testing results, how it works with video instruction, also on our documentation website. You can check this on your if you want. Also, people ask us about dApps. We run demo. We have 3 demo. It's Uniswap, Aave, and Curve. We have login and password to open this demo. You can swap video instruction. We have on testnet bridge, because we use Uniswap and the bridge together on instruction. Also, you can deploy Uniswap locally. We create instruction. You can do it with our testnet 2. Soon we will update instruction to our testnet 8. Why we use login and password to our dApps sites? Sergey can tell about it.
Yeah, so thank you, Alex. So let me start sharing the screen. So yeah, this is generally how our the structure of the nodes look. So there was the the question about it, and basically we will soon post it online and probably on our documentation website, but this, generally speaking, should address the question which was asked. Why we deployed that? There was the question, okay, why do we need Uniswap on the testnet? Because and what to do with this? So obviously, the way the question asked it actually contains part of the answer, because the testnet is launched and built for testing. And generally speaking, Uniswap can allow people to, for example, create some tokens or create NFTs or create something else on the testnet. For example, somebody may deploy their I don't know, gamified apps or different type of app and issue some gaming tokens. And after that, test the swap of these tokens, for example, to water coins, test water coins, and do this process. Actually, our documentation website has the section where you can actually test deploy in your own website. Second dog, waterfall, that network. Yeah, now deploy Uniswap. Here we go. So yeah, basically you can even try setting up your own Uniswap. So here is the guide how to do this. Also, here is the guide how to create different tokens. So here is WRC 721, which is NFT. Here is WRC 20, which is actually fungible tokens. Here are different clients such as Hardhat, also how to install, how to use it, Remix, the same, and Truffle. So these are the clients you can use to deploy smart contracts, and definitely you can deploy some dApps and do some swaps using Uniswap, or deploy your version of Uniswap, or think how you can improve your version of Uniswap and deploy it to us. So maybe create some other swap, how, you know, there were different swapping projects which appeared after Uniswap. Yeah, this is what you are able to do, and this is the purpose for it to be there. So the other question was related to operating system. So we do have low requirements for our workers. It's actually for our nodes. It is 2-core CPU, 4 GB of RAM, which is less than average cell phone has. The question was regarding, so currently Docker is run on Windows, macOS, and Linux, and do we have any plans for mobile or operating system? And yeah, the answer is yes. And the answer contains 2 parts. So first, regarding Linux, Windows, and Mac OS, we are working right now on the one-click setup node. So you definitely are able already to set up nodes using Docker, but we would like to make the process simplified. Because initially the protocol is designed to have a very large number of validators. So let's say Ethereum has what, like close to 900,000 validators on their sharding network. We are able to outperform this number, and technically we are targeting the number of 3 million. It may slightly change going forward, so we may recalculate something, but consensus is designed to do that. And basically the ease of installation and utilization of the protocol will help us in achieving the larger number of decentralization, because this technology by design has been built to be decentralized. Now the next step about mobile devices. So on the previous AMA session and on the on a couple of paper defense procedures, we were touching the topic of light nodes. The paper soon will be released on this topic. So basically, light nodes and light workers are essentially designed to run on cell phones, because we have this kind of light clients on Bitcoin and Ethereum, but the main issue with them is actually they are not full participants of the consensus algorithm. So in particular, so what they do? They store the transaction, not the transaction, the block headers, and they can create transactions, but they have to work with full nodes or archive nodes. It depends how we call them, but basically the nodes which store everything and the nodes which are able to do everything. And what is everything? Everything is they have transaction pool, they are able to create the blocks, and they are able to receive rewards for their participation in consensus. So this is the main difference. We are willing our light nodes and light workers to actually to be able to be like a full participant of the consensus algorithm by performing all these functions, except storing the entire ledger and storing the entire state. So currently, we are at the phase where we conducted first step of three steps of research on the light nodes. So it is designed already how the light nodes can work without storing the entire ledger, but there is still a requirement for them to be maintain very high uptime, and basically there is still a requirement for them to store the entire state. And again, the entire state it is already not a problem for new phones, but still we would like to decrease the requirement for the uptime and requirement for storing the state. So second step of discovery, or second step of like theoretical work of research work on the light nodes will be introducing the so-called concept of blinking. So what is blinking? It is actually going online and offline, and this is what happens with cell phones when we are going to, I don't know, board in the plane, or phone is running out of power. And the third concept would be the separating of the shared state to multiple to multiple devices, basically by for them not to store the entire state, but to store the part of the state, and basically and then having the zero knowledge base based proof of the correctness of the rest of the parts. So these approaches all are described in our papers. And also, as soon as we implemented the so-called subnetwork concept, which is also currently on the first of the three stages, we also will significantly reduce the bandwidth parameter. So this will allow the cell phones to join, and this is the plan. So we can kind of make like a strong statement that we are working on the light nodes to be able to basically cell phones to be able to be part of consensus algorithm. And when the theoretical part of research will be achieved, we are going to we will need to rewrite the clients in native languages for iOS and for Android. And then we are going to launch the full functionality of the mobile devices, and this can push our scalability parameter much further. So if currently we are targeting like millions of archive nodes or full nodes, we will be able to go significantly further than that. So this is what we are working on, and we of course will be reporting on the progress of how we are achieving on the progress of development of this part. Currently, our subnetwork article was recently published in one reputable scientific journal, and it will be soon published on our channel, on our groups, and yeah, on our social media accounts. So with that being said, this is the end of the questions which I was supposed to answer, and I'm passing the word to Yevgen and Alisa, so they can provide some details on the tokenomics. Thank you.
Hello, everyone. I'm Alisa, and I will talk about the rewards. The block production is incentivized with minted rewards for each finalized block of the coordinating network. Earned coins are accurate to workers every epoch. The annualized minted amount depends on the total amount of stake coins. You can see on the screen the formula for how to calculate it. Here, our optimal we consider for now to be 20%, the maximum annualized reward rate at the total stake as optimal equal to 9.6 billion. Hence, we can now calculate the maximum annualized reward rate at different values of S. The formula is on the screen. The figure on the screen depicts the maximum annualized reward rate that could be generated by stakeholders as block rewards at various total staked amounts. When there is a small number of workers, a huge annualized reward rate can be assumed. With 6.6 million staked coins, the maximum reward rate is expected to be 765%. It should contribute to the expansion of the network, which leads to bigger decentralization. However, as the number of workers increases, the reward rate decreases sharply. It reaches its optimal value of 20% with 9.6 billion voters staked. We should note that these rates are for preliminary lab tests and can differ in the mainnet. A minted reward for a produced block can be obtained by considering the values of the annualized minted amount and slot times. Slots per year are calculated as the number of seconds in a year divided by the slot time. Therefore, the minted reward for a block is the annualized reward rate divided by the number of slots per year. On the screen, you can see the formulas. It is important to note that the total time sum over all slots of the coordinating network per year is equal to V. Further, the amount of minted reward per block will be split among the committee leader and members that produce the block in the coordinating network. In these tables, one can see the calculations of the rewards. The first table refers to the period of one epoch, and the second one refers to the period of 1 year. The optimal number of workers we consider here is 3 million, which is 9.6 billion total stake. Our optimal is the same as we discussed before. The first four calculated rows with R, V, B, and W are derived from the formulas I showed before. The total coordinators rewards is the reward per slot multiplied by the number of slots for the chosen period. The average reward is simply the total divided by the number of coordinators. Now let's move to the website. We can see the real situation for testnet. The workers can miss their returns. In reality, that is why the real number is less than the maximal one. The current number of workers is 2,132. Projected voter earnings per worker are calculated as in the table before. Here we can see the maximal, average, and minimal workers' earnings, for example, for each epoch. This chart reflects the number and statuses of workers. This chart shows the workers' total balances and earnings. As the income becomes bigger, the balance also becomes bigger. This chart shows changes in reward amounts for all workers. Now I will give the floor to my colleague Yevgen to talk about how a validator can earn in the shard network and the distribution of block rewards.
Thank you for passing me the word. I would like to this one. Thank you. I would like to add some details about transaction fees and the reward distribution for block producer. So each transaction fee is split into two portions. The 2/3 is burned, but the 1/3 is left for a validator in addition to the reward for block producing mentioned before. Clearly, this part of validator's reward depends on the number of transactions. However, in the future, the sum of transactions fees will be equal or even greater than the amount minted for a block. And by the way, the tokenomics model may become deflationary. Please, next slide. Thank you. In reference to the reward distribution for block producing, not only the block leader is enumerated. The minted reward is split into different portions, so you can see this in the figure, and all participants of the block producing process, committee members, voters, as well as leader, get their part of the reward. To our mind, this incentivizes the permanent involvement of all members and provides a fair division of rewards between them. Please, next slide. Thank you. Thanks for these questions. More details can be found at our website. You can see these links on the screen. And thank you for your interest in our work. I'm done.
Yeah, thank you so much. Thank you so much, Alisa and Yevgen. So I think if there are no other questions, I would kindly request us to look to the group. And if no one is asking any follow-up questions and not joining us, we can conclude today's session. So while we are watching the networks, the channels, I would like to say that we will be conducting AMA session every 2 weeks. So probably this time on Tuesday, it will be the time when we will be doing this. So right after this session, we will publish the list of questions, so you are able to combine them, and in 2 weeks we will provide the responses for the rest of the questions which has been asked. Do we have any other questions to address? Well, I think the answer is no. So yeah, thank you for being with us. Thank you for watching it after the after this session, the recording. And yeah, we look forward to speaking more later. Thank you, dear colleagues, for participating. Yeah, and yeah, wishing you have a great rest of the Tuesday. Thank you.